Okay, Wildcats. Today we're looking at Thursday, February 1st, cube and cube root equations. But a little note, on Thursday, February 1st and February 2nd, I'm going to be down at Johnson Space Center in Houston presenting a workshop at NASA's teacher conference. So I'm going to be absent on Thursday, February 1st and Friday, February 2nd. And then I'll also be absent on Tuesday, February 6th. Now, because of that, what I'm going to have you do is finish a review for Monday, and then we'll go over questions on the review, and then you'll have the day while I'm going to review, and then we'll have the test on Wednesday. Okay? So if you have any questions on that, please let me know. But other than that, if you would just update your table of contents. All right, now your table of contents are updated. Let's take a look at the notes. All right, solve cube and cube root equations on page 52. Solve cube root equation steps. Step 1, factor, using the sum and difference of cubes or by grouping. Step 2, solve. Linear and or the quadratic. A special note, if the equation is not factorable, then graph the equation with the solutions. Okay, so now let's look at solving cube root equation steps. Step 1, isolate the cube root. Step 2, raise both sides of the equation to the power of 3. Step 3, simplify and solve. All right, now your notes are updated. Let's take a look at the examples. Now, I know in the previous video I didn't have lines, and I know that was like seconds and minutes of your life that are wasted, so I've taken the time to draw lines, and let's hope that no one knocks on the door. And so with that, let's look at solving each equation. All right, so this is a cubic equation, so our first step is a factor, so we can see that it's a difference of cubes, so we know that A is x and b equals 2 because x cubed is x cubed and 2 cubed is 8. So we know that that is x minus 2, and I'm using the sum or the difference of cubes formula, and if you need to, you can review that in your notes, times a squared, which is x squared, plus a times x, which we can write as b times x, is 2x, plus b squared, so 2 squared is 4. And that's equal to 0. So you might have seen it look kind of weird, the linear and quadratic. Well, that's linear, that's quadratic. So we're going to solve the linear portion and then the quadratic portion. Okay? So we said x minus 2 equal to 0. So we add 2 to both sides, so x equals 2. All right, now we're going to set x squared plus 2x plus 4 equal to 0. And we're going to look to factoring. So we look at 1 times 4 and 2 times 2 are the only combinations that make 4. None of them will combine to be 2x, so we know that this is not factorable. Okay, so we're going to use the quadratic formula. So a equals 1, b equals 2, c equals 4. So x equals negative 2 plus or minus the square root of 2 squared is 4 minus 4 times 1 times 4 divided by 2 times 1. So then x equals negative 2 plus or minus square root of 4 minus 4 times 4 is negative 12 divided by 2. So x equals negative 2 plus or minus. We can rewrite the square root of negative 2 as the square root of negative 4 times 3 divided by 2. Well, the square root of 4, negative 4, is 2i, and the square root of 3 is the square root of 3. So we have x equals negative 2 plus or minus 2i times the square root of 3 divided by 2. So we divide negative 2 by 2 is negative 1, and 2 by 2 is 1. So x equals negative 1 plus or minus 1i square roots of 3. Which makes sense that we have 3 solutions because we have x cubed, so that tells you there's 3 solutions. The highest power tells you solution. So we have x equals 2 and x equals negative 1 plus I squared to 3 and negative 1 minus I squared to 3. All right, so let's look at example 2. All right, now I see 4 terms, so I'm going to start by factoring by grouping. I can factor out an x squared from the first 2 terms, leaving x minus 1 plus, and I can factor out a 2, leaving x minus 1. Since these are both x minus 1, we know that it's factorable by grouping. So we have x squared plus 2 times x minus 1 equal to 0. So we can set x squared plus 2 equal to 0 and solve. So we subtract 2 from both sides, we get x squared equals negative 2. We square root both sides. Remember, it's plus or minus. So x equals plus or minus the square root of 2i. All right, now we set x minus 1 equal to 0. We add 1 to both sides, so x equals 1. All right, now let's look at example 3. All right, so example 3, and look, forgot some lines here. I'm gonna add those real quick. All right, so we see 4 terms, so we look to factor by grouping. So then we factor out an x squared, leaving x plus 2. And then we can factor out a negative 1, leaving 5x plus 6 equal to 0. Since these aren't the same, it's not factorable by grouping, so there's nothing else you can do. So it's not factorable. Since it's not factorable and you can't use quadratic formula because it has the highest power of x cubed, we go to this in our notes. If the equation is not factorable, then graph the equation with the solutions. Okay? So let's do that. So we're going to go to on, new document, no, add graph, and we're going to graph that. So x cubed plus 2x squared minus 5x minus 6. All right, so we draw our sketch. And it looks like it goes out 1, 2, 3, 4. So I'm going to make 4 tick marks. 1, 2, 3, 4. Goes out 1, 2, 3. So 1, 2, 3. And really, we don't need to be concerned with the tick marks on the y-axis because we're looking at the solutions, and that's what crosses the x-axis. So it looks like we have solutions at -3, -1, and +2. So we just draw a sketch. I'm going to list our solutions. So our solutions are x equals -3, x equals -1, and x equals 2. All right, so let's move on to example 4. All right, example 4. So we're solving a cube root. So our first site is to isolate the cube root. So we're going to divide 7 by both sides. 7 divided by 7 is 1, so you're left with cube root of 5x minus 7 equals 84 divided by 7 is 12. Then we cube both sides. That becomes the power of 1 to get 5x minus 7 equals 12 cubed is 1,728. We add 7 to both sides. Get 5x equals 1,735. Divide both sides by 5. X equals 347. All right, now let's take a look at example 5. So we're solving the cube root. So our first step is to isolate the cube root. So we're going to add 6 to both sides. So you get the cube root of x plus 180 equals 6. We're going to cube both sides. That becomes the power of 1. So x plus 180 equals 6 cubed, which is 216. We subtract 180 from both sides. So x equals 36. All right, so example 6. First step is to isolate the cube root. Well, they're already isolated. So now we're going to cube both sides. Okay, so this becomes the power of 1, so you get 1x plus 6. Now this cube means you multiply 3 times. So that's 2 times x minus 1 to the 1/3 power times 2x minus 1 to the 1/3 power times 2x minus 1 to the 1/3 power. So we have 1x plus 6 equals 2 times 2 times 2 is 8. 1/3 plus 1/3 plus 1/3 is 3/3, so it's the power of 1. So that's just x minus 1. All right, so then we have 1x plus 6. Distribute the 8 is 8x minus 8. We're going to subtract 1x from both sides. So you get 6 equals 7x minus 8. Add 8 to both sides. You get 14 equals 7x. Divide both sides by 7. 2 equals x. All right. So at this point, you can start working on the assignment. And I'll tell you what, since I'm going to be absent that day, what I recommend doing is pausing the video, working on the assignment, and then at this point, once you're done with the assignment, you can click play and I'm going to show you the assignment so you can check your work, okay? So let me just leave up 1, 2, and 3 up for a few seconds so you can pause it. Now, on number 1, I ran out of space, so I had to put this in parentheses, but this is all being divided by 2. All right, now let's look at 4, 5, and 6. All right, now let's look at 7, 8, and 9. All right, and then 10, 11, and 12. All right, well, I hope that helps. Check your work, and I guess I will see you back when I get back from Houston on Monday, February 5th. So as always, have a wonderful Wildcat day.